Da-na-na-na-na, the Zach and Mitch Show. Da-na-na-na-na, the Zach and Mitch Show. Hi, I'm Zach,
And I'm Mitch.
and we're here today to talk to you about two very different kinds of molecules.
As you may or may not know, a molecule is a collection of atoms bonded together.
Exactly. And the molecules we'll be discussing today are carbon dioxide and carbon monoxide.
Carbon monoxide is produced by things like cars, stoves, and the burning of coal, while carbon dioxide is produced from just breathing.
Carbon monoxide is very dangerous. When too much is inhaled, it can be lethal. Carbon dioxide, on the other hand, poses no threat to our bodies.
Let's talk about breathing. In a breath, molecules in the air, which has some oxygen and carbon dioxide in it, enters the bloodstream through the lungs. This is how we get oxygen to all of the cells in our body.
When oxygen enters our bloodstream, it attaches to a protein in your red blood cells called hemoglobin. This attachment is called bonding.
Within this protein is a molecule called heme. This molecule is where oxygen and carbon monoxide bonds to be carried around in the blood.
Here's a drawing of the heme molecule. As you can see, there is an iron atom, that is what the Fe means, in the middle of it. This is specifically where the carbon monoxide and oxygen bind.
The problem that comes with having carbon monoxide in the air when you breathe it is that it really loves heme.
It sure does. It loves it so much that it takes away spots on the hemoglobin protein for oxygen.
It's like taking the last seat at the lunch table with all of your friends, so you have to sit somewhere else.
This happens for multiple reasons. Before we begin that discussion, we have to talk about things called molecular orbitals. These orbitals are where electrons tend to hang out.
For an atom to bond to another atom, these orbitals have to overlap.
It's like trying to fit a key into the lock of a correct shape. If the orbitals can't overlap because they have the wrong shape, then they can't fit together and bond. The carbon monoxide molecule, similar to iron, has its own set of orbitals that look like this. Just as a reminder, orbitals are just where electrons, which cause bonding, tend to be located.
Once the carbon monoxide molecule comes in and binds to the iron, they match up and hold on to each other tighter. They hold on so tight that they have a hard time letting go of each other because their orbitals match up so well.
But why does carbon monoxide like iron more than oxygen?
Like the carbon monoxide, the oxygen binds to the iron in the heme group. However, the orbitals don't match up as well.
Due to the difference of charges on each side of the carbon monoxide molecule, it can act almost like a magnet.
Another question that people ask is, why does carbon dioxide not have the same effect? It looks pretty similar.
Well, your body produces carbon dioxide, which is what you breathe out. So I guess that is a good thing that it isn't toxic.
But why?
Carbon dioxide doesn't bind very tightly with the iron atom. It doesn't match up with iron very well at all.
Also, carbon dioxide tends to dissolve in the water in your blood instead of bond to the iron like carbon monoxide and oxygen do.
The few times that carbon dioxide bonds directly with the iron in heme, it is not tightly bound and can easily be replaced by oxygen.
Unlike with carbon monoxide's bond to iron, carbon dioxide's bonds are weak. So when a lot of oxygen is around, oxygen can switch places with it fairly easily. This is what makes carbon dioxide fairly harmless to humans. Carbon dioxide flows easily in and out of our blood, making it easy to move from the cells to our lungs to then be exhaled.
Since carbon monoxide is so dangerous, how can you prevent carbon monoxide poisoning?
Well, there are detectors that you can install in your house that sound when there is carbon monoxide present.
Also, get your furnace inspected regularly since it can be a source of this deadly gas.
Carbon monoxide is colorless and odorless, so if your alarm goes off, evacuate and call 911 immediately.
Wow, great advice, Mitch.
Well, that wraps up our video. Hopefully now you know why carbon monoxide is poisonous and carbon dioxide is not.
Bye!
Bye!